I took a while for the to run.
Sorry about that.
No worries.
Okay, well, welcome, Megan, and welcome those who are watching this as an archive webinar. So this is the last webinar of the quarter. Okay, for a recorded regular webinar tomorrow, we repeat it again, but this is the last one that'll be recorded. I don't record the second one because it's the same. And today's a very different day than usual. We have Chapter 13 to look at, but Chapter 13 is very short. It is one example, basically, and that's all you need to know. There's not a lot to it.
Okay.
Very light chapter. I think you'll agree. I think it's very short quiz, and the discussion post, I decided to make it very simple. If you can't do it, then there's something wrong with you, I promise. But it is so important. You want to post in the discussion forum. Thanks for showing up. So the plan today is we will be going over just an example from Chapter 13. And then after that, I'll talk about the final exam, because the final is the last bit for this course. So I want to tell you, first schedule. We're done with basically everything except Chapter 13 of the final, okay? And this webinar we're in right now, which is part of Chapter 13 of the final. So that's where we are right now. It is, but I don't want to make anything light of the final. I have some grading to do. I'll look at your project starting tomorrow. I still have some reading to do on your week 10 discussion. Today was a big teaching day. Tomorrow I'll be able to look at the rest. Josephina, thanks. I was worried we'd have 0, and now we're starting to get a nice score. 3 of y'all. So as I mentioned, there's not too much new material, but there's a lot to talk about to get you ready for the final, because this is a review for the final. Talk about some resources that you can find, etc. So that is the plan of the day. Are there any questions before I move forward? Any questions? Okay, so the final exam, by the way, must be taken by Wednesday, December 6th. So that is a strict requirement. So I can get it to you tomorrow if you needed it. So that gives you lots of time to plan. I don't recommend taking it tomorrow, because if you haven't started studying, that may not be enough time to study for it. But I can get to you whenever you need it. You just have to let me know. I haven't had anyone. The earliest I have someone taking it this Thursday. I've not written it yet, but I can write it tonight if I needed to. Otherwise, I plan to write it tomorrow. I know what I'm writing already. I just got to write all the details of it. If you haven't let me know already, you need to let me know where you're taking the final, and I'll make sure it's sent there. If it's the same place, just let me know it's the same place, and that's great. If it's best if you let me know when you're taking it, because that gives me a deadline of when I have to send it out. Okay, so especially if you're taking it early, like the person who's taking it Thursday, I needed to know so I can make sure that that's sent to their proctor by then. This week is a light week. We only have a short Chapter 13 and a very easy discussion, and I did that so you can focus on studying for the final, because that's the big deal for right now. I plan on grading the final, and I don't take a long time. I should have it, if everything goes well, on Thursday, graded by Thursday. That's my hope, because I'll be getting it by Thursday morning. The only reason I wouldn't have it all graded by Thursday is if there's still people who haven't taken it yet. I mean, actually, they have to have taken it, but if the proctor forgot to send it to me, that actually happened in the midterm. One of the proctors, they took it, the student took it on time, and the proctor didn't send it to me. So I had to go chase the proctor down. But otherwise, I will get your test done on Thursday. It won't show up in your transcript for another week or so. I put it there, but the college doesn't do it until, I think, like Tuesday or Wednesday after finals week. So that's just a note. If you need it to show up on your transcript, you have to be patient on that one. But at least I'll let you know how you did. Okay. So that is the plan. I thought I'd start out with a little bit from chapter 13. Just one second. So chapter 13 is the last chapter of the quarter, and it's not the last thing that happens in statistics, but it is the last thing that happens in our statistics class. Again, some of you, if you get a master's degree, for example, will take another statistics class. And then you'll learn a lot more details. And in fact, we are going to do ANOVA. We're going to do ANOVA today. And I do not expect you to be ready to do research-based ANOVA after this week. I expect you to maybe think you can do it, but you won't be able to do it. Just let you know, there's a lot more to it than I'm going to show you. And in fact, a little disappointing, I often will read other articles that are sometimes peer-reviewed journal articles that use ANOVA, and they usually do it wrong. So kind of sad. But we're going to play around, and we're going to use ANOVA. Okay, so ANOVA is it's really called analysis of variance. You don't have to understand why at all, because there's some math involved, and you can just trust me that the word analysis of variance is the right word, even though for us it'll have nothing to do with variance. It'll have to do with means. So we have already looked at how to do a hypothesis test for a mean, a hypothesis test for proportion, a hypothesis test for two means, a hypothesis test for two proportions, hypothesis test for paired data, hypothesis test for qualitative data when you want to find out a distribution, qualitative data where you want to find out two distributions and see if they're the same, two different questions and finding out if they're independent. We've talked about a hypothesis test to find out if two things have a non-zero correlation. And this is the last thing to do. And that is to find out if you have multiple means, to find out if they're all the same, or if maybe they're not all the same. That means two of them might be different. So that is what the last section's about, is when you're comparing more than two populations. Okay, we've only done two populations, like men and women, but a lot of times you have more. It might be you're looking at the different races, different ethnicities, and finding out if there's a difference. And there's lots of ethnicities. You don't want to just choose two of them. You want to say, of all the different ethnicities, is there a difference in whatever you might be interested in? Height, or grades, or income, or whatever it might be. And you could do a hypothesis test, and we're going to be using ANOVA. Okay, you could also do something like, is there a difference in average height by state? Right? Are Californians taller? I don't know. Maybe people in New Mexico are the tall ones, or maybe New York, or maybe they're all the same. So what we're going to do is we're going to be able to decide whether they're all the same, or maybe they're not all the same. And that's what we're going to be looking at. We're not going to find out who's different. We're only going to find out if they're all the same or not. So that is the plan of the day, to find out how to compare multiple population means. Any questions on that? Okay, so let me share. And I have a sample question in a minute. Okay, so here's the sample question. So here's the question. It says, and I only have one question today. Like I said, this is a short section. We're only going to do one question, and then we'll talk about the final example. And what this question says is, suppose that a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. Okay, so the data from the study is shown below. That pizza looks really good. It is pizza. Gonna share with us? Okay, so the data from the study is shown below. And we have our different races: white, black, Hispanic, other. And there's two questions. The first question is, what assumptions must you make in order to perform an ANOVA test? And the second question is, show all the details of the ANOVA test and state your conclusions in the context of the study. Okay, so I want to mention a few things. We have a lot of assumptions to make with ANOVA. And you don't want to take these lightly. Most of the time, you're not going to be able to use ANOVA because of the assumptions. It's just not possible. But we'll talk about them. So let me list the assumptions that we're going to have to make. So notice we have whites, blacks, Hispanics, and others, 4 different populations. So we have seen the assumption that when you have a small sample size like this, what do you have to assume to do any hypothesis test when you have a small sample size on a quantitative study? You guys remember? See if you can put in the chat box what assumptions need to be made. Yeah, if n over under 30, so if it's under 30, what assumption has to be made? Because we have under 30. Clearly, if you look at any of them, normal, okay? So that's the first assumption. So let me write that out. So each distribution is normal. Okay, and approximately is enough. I'm going to write approximately. Okay, if you have each of them have a greater than 30 sample size, then the central limit theorem will give that to you. But we don't. You notice that? We have, for example, for the blacks, we only got 4 in the sample. So in a way, this is a ridiculous study because you shouldn't do a study with only 4, especially if you don't know it's normal. Even if you do, it's probably a bad idea. Any questions on that? Okay, and others are also 4, and even the whites and Hispanics are 6. Really tiny, tiny, tiny samples. Bad idea. Assuming the distribution is normal, do we really know anything about the distribution of how far people live from the library? Probably not. I have no clue. So this is a very bad assumption, but to do an ANOVA, we have to make that assumption. So already it's a bad study. 2. Okay, the next one is not going to be obvious, but I'm going to tell you have to assume it. So the standard deviations of each or of the populations are all the same or close to the same. If the sample sizes are similar. Once again, do we know anything about the standard deviations of how far people live from the library for each of these races? Yeah, we don't know anything, right? So this is a very bad assumption too. So I want to warn you that ANOVA is a very dangerous test to use. Okay, ANOVA is a very dangerous test to use because you got to have these 2 assumptions. And these are the 2 biggies that are the dangerous ones. Okay, then there's some others that are a little easier to deal with. So 3 is the sampling was done in a random fashion. I'm just going to write the sampling technique was scientific. Okay, so it doesn't have to be purely random because that's impossible. But for example, if you did a good job with stratified sampling for all of the issues that matter, that's okay. Or if you did a good job with cluster sampling, and as long as you have a representation of the sample, that's good enough too. So that one is also hard to do, but at least we understand it a little better because that was project 1. Okay, number 4. Number 4 is you have to make sure that they're independent. The populations are independent. For this example, that's also pretty easy. You wouldn't guess that the first person has anything to do with the second person. The first white person has anything to do with the second black person, or the first black person. It's just You ask a bunch of people, and that's fine. Independents are an issue if you try to do some kind of multiple paired study. So for example, if you ask somebody 5 survey questions and wanted to compare the means of each of those people's 5 survey questions, you can't use ANOVA. Okay, number 5. Number 5 is we need to make sure that all the studies were done in the same way. So all the populations were, I lost something. Oh, I know what I lost. It needs to go here. All the populations were surveyed in the same manner. That's an easy one. That usually isn't, if you do your own study, it's not a problem. The issue there is that if you get a collection of studies from different states, for example, you want to compare states, and you didn't do the work, yeah, they may not be the same survey question, for example, even though they get at the kind of same thing. Okay, so obviously if you ask the whites how many kilometers you live from campus, and you ask the others how many miles you live, from the library, and you ask the others how many miles you live from the library, then that doesn't make any sense. So that's an easy one. 1 and 2 are the big troublesome ones. 3 is difficult because you have to do it, but 1 and 2 are sometimes impossible. This is a bad example because there's only sample size of 4 for 2 of the races, so you wouldn't want to do that. Okay, are there any questions at all on these assumptions we need to make? There's a lot of them. Okay, so if you don't have questions, let me go on and go through, and we're going to make the assumptions, and we're going to do ANOVA. So show the details of the ANOVA test, state your conclusions in the context of the study. So we'll start out with H1. And this one, there's going to be a lot of mu's, so I got to draw it. So H1 is that the population mean number of miles that they live from the library is the same for whites, blacks, Hispanics, and others. So in particular, we'll say mu sub W equals mu sub blacks equals mu sub Hispanics equals mu sub other. So notice that the statement for the I'm sorry, this is H not H1. Let me fix that. So notice that the statement for H naught is all in symbols. It's the population mean. It's the population mean for each of these 4. Any questions on that? Okay. On the other hand, if we want to get H1, it's going to be in words. Theoretically, it could be done in symbols, but what I found is that it's a disaster when I expect you guys to learn the symbols. So words are a lot easier for H1. So H1 is, it's a weird thing, is that it seems like you might think that the opposite of all the means are the same is all the means are different. But that's not the opposite, because maybe a couple of them are the same and maybe a couple of them are different. And that would mean that not all are different and not all are the same. So the way we can say it is that at least 2 of the population means distances from the library differ by race. Any questions on that? Any questions? Okay, so now that we have that, what we need to do is we need to use our calculator. So let me go and share the calculator. So here's the calculator, and we're going to go to Stat. We're going to go to Edit. We're going to clear out L1, L2, L3, and L4. So I'm just going to go to each of them. Hopefully, by now, you should all know how to clear out these guys. Then we're going to go and put in our values. We had 15 was the first white answer, 4 for the next one, 11 for the next one, 9 for the next one, 3 for the next one, and 2 for the last one. And then for the blacks, we had 12, 1, 6, 6. For the Hispanics, we had 9, 17, 5, 14, 7, 1. And for the others, we had 18, 11, 2, and 8. Any questions so far? Okay, so ANOVA turns out to be pretty easy to use. You just put in your data like you expect to do, and we have 4 columns, so we make sure we do an L1, L2, L3, and L4. Then we go ahead and go Stat. Used to this, we get a test. Up arrow, definitely up. You don't want to go down because it's right there. You hit the up arrow once and you're on it. Then I hit Enter. This one's a lot different because at this one, they don't ask you for L1, L2, L3, and L4. Or they ask you just ANOVA. And then we're going to go second 1, and then comma. And then second 2, and then comma. And then second 3, and then comma, and then second 4, and close the paren. I think I'll hold for a sec, make sure there's no questions. Are there any questions at all on getting through the calculator? Any questions? Okay, so now I hit Enter, and it gives me what I need. So let's first notice that F is something we have not seen before. We've seen a lot of distributions. Normal distribution, which they use Z. We've seen the T distribution, which is an extension of the normal distribution, you use T. We've seen the chi-squared distribution, right? We've also seen binomial distribution and uniform distribution. So F is another distribution. Okay, and the test statistic for F is 0.3339. Okay, all right. Then the next one is the p-value, and that's the important one. P is 0.8 about. So P is 0.8. I think I'll write this down so I don't lose it. P equals 0.8. F equals 0.33. So I'm going to go back so I can start typing. Okay, so notice that our test statistic was F was about 0.33, and our p-value was about equal to 0.8. Any questions on that? Okay, at this point, we've done so many hypothesis tests. You should all know how to write your conclusion. I want you to put your conclusion in the chat box. So I'm going to give you a couple minutes I want you to type your conclusion in the chat box based on, we know that the p-value is 0.8. Notice that a level of significance was not given, okay? But you don't need one. Not if you have a p-value like this. And typically, no one's going to give you a level of significance, okay? You're just going to have to understand what the p-value is all about and what you can do, okay? So, Josephine, you got to start, but then let's hear the rest. So Josephina says there's no significant evidence, but let's hear some more. That the distance, looks like she's typing some more. Okay, and you should all be typing, by the way, not just Josephina. Megan and DJ, you should type also. Okay, I don't see you all typing, but hopefully you will. Okay. All right, so let's take a look. Okay, so just you kind of have the right idea, but I want to remind you what you do when you have a large p-value. You got the beginning, and that is there is, I like to write statistically insignificant. Evidence to make a conclusion that, and then all you have to do is restate H1. We have it in words that at least 2 of the population mean distances from the library differ by race. Okay, since we have H1 already written down, it's very easy when it's written in words. You just rewrite it and say that we don't have evidence to say that. And that's how you make your conclusion. Okay, sometimes H1's in symbols, and then you do the same thing, but you have to convert the symbols to words. Any questions on that? So Megan, you knew there was statistically insignificant evidence. That was good to conclude that and then maybe you have the right idea after that. Any questions? Any questions on this ANOVA example? Any questions? So I want to give you some big warnings. The first one is that these assumptions would be ridiculous in the real world. Like, you would not ever do an ANOVA test with sample size of 4. Okay, that's just silly. So I only made this example so that we didn't have to type so much. I didn't want to waste your time watching me type all day long. Typically, you get a large sample size for each of the populations, and you're much better off. If you do the same sample size, you also check for the standard deviations or the variances to make sure those are the same, because that's important. And there is a test for checking for the standard deviations being the same, but that's beyond this class. That would be a intermediate or an advanced statistics class, and this is just elementary statistics. The other thing is that if you do have statistically significant evidence, then you know at least 2 are different, but you don't know which 2 are different. Maybe they're all different, maybe only 2 are different, and that takes more analyses, which would be, again, a more advanced class. And you do something called a Tukey analysis. So again, this tests for everything. But right now, we stop at talking about just being the same or not being the same. And that's as far as we're going to go. Are there any questions at all with ANOVA? I'm just going to do this one example, but I'll be happy to go further on questions. Any questions? Okay. If there's no questions, I think I'm going to talk about the final, because the final is coming up. And I think I want to share my desktop with Canvas. And that's something you guys all have is Canvas, obviously. So just 1 minute. I just got to reshare. Okay, so first thing, let me remind you, syllabus is everything in the class in terms of the rules. And let me remind you on the syllabus. The proctored final exam is by December 6th. Okay, so that's the last thing in this class. It is over on December 6th, the course is over, and that's it. So then you could, cry because you don't get to do any more statistics, and I know how much you love this, and but maybe someday you'll take an advanced statistics class. But that's it. So December 6th, it must be taken. You can take it earlier. That's up to you. 300 points is a lot. That's 30% of the course grade is the final exam. So it is a lot, but everything else is, important too. The final is the biggest part. It is comprehensive. So it has potential to cover everything or anything from the first day of class until ANOVA. So that's pretty important to note. It's a little more weighted on the last couple weeks, okay, because you haven't been tested on that yet. So it's a little more weighted on chapters 10, 11, 12, and 13 than it is on chapters 1 through 9. Okay, so that's important, is to really understand what you're getting at. The rules for the proctored final are identical to the rules for the proctored midterm. So in terms of the rules, that means that you're going to have 2 hours to do it. It has to be taken at a proctor center, just like before. Most of you are probably going to take it at the same proctor center, but you don't have to. You can choose a different proctor. You can come up to Tahoe. I don't know, maybe I'll check as I'm talking how hard it is to come up to Tahoe, but I'll know in a minute. Because there are issues of coming up to Tahoe. Whenever you plan something, you should worry. And those who don't live in Tahoe, do you happen to know what the big issue is in getting up here? Anyone know? Not hearing, but the big issue is snow. So I've had students that plan to come up here, and then the snow happens and they change their mind. So I'm looking at the weather part right now. We got a chance of snow on the weekend. Monday is mostly sunny, but I don't believe 7-day reports. So who knows? So if you are planning to come to Tahoe, make sure that you're ready. Wait a few more days and see what the weather forecast is starting to look like. And that is important. Okay. So if you're not coming to, or if you live in Tahoe, there's no problem. But if you don't live in Tahoe and you want to take it to Proctor Center, you can take it to the same place, no problem. Okay. The rest of the rules are exactly the same too. You get a 3-inch by 5-inch note card. You can put anything you want on that note card. I do not believe in testing you on memorization, because that's something you can just do with us. You can look anything up quickly. So I don't believe in testing with memorization, but I do believe in testing you in understanding of concepts. Any questions so far? Okay, so that's pretty important. Next, I want to go to the modules and show you some things that we've got. So if you go to the very last module, which is comprehensive final, I have some things for you. I'm going to start with this review applets. Okay, so in this review applets, what I've done is I've programmed a couple applets that will help you study. The first is practice classifying statistics problems. So this helps you decide which test to use, whether it's confidence interval or whatever it might be. Any questions on that? Because it's a final exam, I recommend you hit select all, because you need to practice all of them. I will also tell you that is going to be, it's going to be like question 1 or question 2 on the final exam, and there's going to be many parts. So to me, this is a very important part of the course, is to be able to look at a scenario and decide what test to use. If I hit submit, then it will give me some choices. So here we go. An atmospheric scientist is studying the relationship between global CO2 levels and global temperatures. He has the data of CO2 levels versus global temperatures and wants to predict the global temperature if the CO2 level becomes 290,000 parts per billion. So let's see in your chat box, see what your guess is. Tell me which of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different possibilities is the right one. So put in your chat box which one you think it is. You got a 1 in 15 chance if you have no clue. But you have a 0% chance if you don't write anything. So you should definitely try. So let's see if you can put in your chat box what you think the right test is. Test or confidence interval. Let's see, I don't see all you putting it in, but you should be putting it in. Hypothesis test for paired data dependent samples. I'll give it a minute or so, see if everyone agrees. All right, I'm not seeing you all jump in. Maybe I'll just try it. Okay, so let's try hypothesis test for paired data dependent samples, and that wasn't right. Okay, so don't just go and find another one. Let's see what it says. It says this is not a hypothesis test since you want to estimate something. Please try again. Right, because it says we want to predict the global temperature if the CO2 level becomes 290,000. So try again. And we'll eventually get it, I promise. Give you a minute. All right, you could all try. DJ, Megan, Josephina. Dependent homogeneity. Should we try that one? So test, chi-squared test for homogeneity, I think is what you meant. It's the only one with the word homogeneity. Okay, still not a hypothesis test. Okay, this isn't a hypothesis test, so it's not going to be one of the hypothesis tests. That's a hypothesis test, right? But it was a good try. Okay, confidence interval for paired data. Let's try it. Okay, confidence interval for paired data dependent samples. Not quite right either. We're given a value for one of the variables. We want to estimate the other. Try again. So try a different one. Okay, prediction for a single value of y for a fixed x. So let's try it. And that's correct. Okay, notice that we have two variables and we're trying to predict the second variable, the dependent variable, given a value of the independent variable. And that makes it prediction of a single value of y for a fixed x, which, by the way, is that regression analysis stuff, chapter 12. So the most recent. Okay, so how many of these do you think you need to do? Okay, Josephina says 100. Okay, and the answer is you know you've done enough if you just keep getting them all right. So keep going until you just are getting them right. You get the idea. So promise me you'll practice, because that will really help you for the final exam. And I promise you, you will get a question, okay, that's like this, where it's a matching question, where I'm going to give you all this big list on one page, and then on the next page, you'll have a paragraph, a bunch of paragraphs, and you have to say which from the list is it. And if you practice a lot, you'll get better at it, and you'll be able to do it. And if you don't practice, it won't go well for you. So notice that there's 15 choices. Don't hope for just luck. You really want to get good at it. Any questions at all on this particular part of the test? Because this is pretty new for y'all, because you haven't had a lot of these kind of questions. But you have had to decide which test to use. So now I'm just straightforward saying which test to use, and you have to decide. Because if you can't decide what test to use, not only will you get this problem wrong, but you get most of the rest of them wrong too, because you'll just be on the wrong track. This is like step one of every problem, is to figure out what you need to do to start. Any questions on that? Okay, so if I go back, then I also have practice true-false questions involving elementary statistics. So this is also going to be on the test. Okay, you had true-falses on your midterm. Now you're going to have true-falses on the final. This gives you kind of the idea stuff instead of the calculation stuff. That's where the true-falses are. And what I recommend is select all, because we're studying for the final, and the final covers everything. So now, hopefully, you can read all of these things and you understand what they mean. So I hit submit. Okay, if A and B are independent events, and the probability of A is 0.37, then the probability of A given B is equal to 0.37. True or false? Okay, unlike the last one, if you guess wrong, you got a 50-50 chance. Okay, let's try true. And yes, it's true, because with independent events, probability of A given B is always equal to the probability of A. Okay, same idea. I recommend practicing these, and you know that you're done if you do a whole bunch of them in a row and you just get them right. Okay, where you're not guessing, you're actually understanding. Okay, and there are hundreds of these I put in, by the way, of each of these true falses, and there are hundreds of the scenario question. Okay, so strongly recommend you practice those, because you will be getting true false questions, and you will be getting these matching questions that I showed you a little bit ago. Any questions on that? Okay, some other things I will guarantee you're going to get. I have not completely written your test yet, but I know some things I'm putting on it. I will put a problem from chapter 12. Chapter 12 is too important not to have a question devoted to it. So do regression analysis. So that means when you go, and let's go over here. Well, I'll just talk about it. when you go to the quizzes, it asks you to like choose which is the right one. So what I recommend doing is not reading that, reading the paragraph at the top, doing the full regression analysis, and then go choose which is the right one. Instead of looking at the 4 choices and seeing and just clicking. There's less learning when you click. There's much more learning when you're writing. So if you write down the full regression analysis, you'll do much better in terms of studying and learning. Any questions on that? There will be one problem, okay? There'll be 1 or 2 problems from chapters 11 and 13. Okay, that'll guarantee for you. So know how to do those and know what test to use or it'll go badly for you. A couple things that you must do is if H naught has mu in it, what words must be in your conclusion? When I say, what is the conclusion for a hypothesis test? If you see mu, what words must be there? 2 words. What 2 words must be there if you see mu? Yeah, population mean. If the words population mean are not there, and you have mu in your H naught, then I take off points. Okay. If you have p, as in proportion p, for H naught, you must have population proportion. Okay. Or you could have the proportion of all, or the percent of all. Those are the choices. You can't have the mean of all. You have to have population mean. That has to do with the way it's worded and the way you read things. Okay, if it's goodness of fit, or if it's homogeneity, what word must be there? If you're doing a goodness of fit test or a homogeneity test, what word must be in H naught, H1, and the conclusion? No, those don't come from, difference doesn't have to be there. Not all of them have a difference. It's really important. Now, dependent is for chi-square test for independence. That's not homogeneity and goodness of fit. That's a different test. One more guess? Population, that's important, but doesn't have to be there. So let me tell you, distributions. And distribution for goodness of fit, distributions for homogeneity. Remember that? Okay, so you must have the word distribution or distributions when you're doing goodness of fit or homogeneity. Okay, and that's important. That's important. I will take out points if you don't. If I say state your conclusion, you're just supposed to say there is statistically significant evidence or there is statistically insignificant evidence, and then continue on from there. Okay? Only if I ask you to interpret the p-value. Okay? Not if I say state the conclusion using a p-value. That's different than interpret the p-value. So note the difference. Okay, if I ask you for a confidence interval, there will be a confidence interval question. Then, how, in the conclusion, what words must you have? Let's say I ask for a confidence interval with a 95% level of significance. True mean, maybe, but it could be proportions. So what words must be there in the conclusion? Any thoughts? Should I tell you? Maybe I'll tell you. With 95% confidence, and then dot, 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 dot. Okay, so if I ask you for a confidence interval, and you're supposed to state your conclusion, it starts out with 95% confidence, or 90% confidence, whatever percent it is. Any questions on that? Okay, one of the things you're going to have to do is study the old stuff, and sometimes that's hard. Okay, so the old stuff includes things like probability, Chapter 3, that was a tough one. You should know sampling techniques, stratified sampling, systematic sampling, cluster sampling, convenience sampling, random sampling, all the different samplings. Make sure you understand what the standard deviation is, and make sure you understand what the standard error is. You should be able to read the different plots. So you should be able to read a histogram and understand it. You should be able to read a box plot and understand it. You should be able to read a stem and leaf plot and understand it. Okay? So again, review is important. Practice problems from way before. Some places you can practice. Let me go back to the module. So there's a bunch of places. One of them is if you do practice final. Click there. This gives you some practice problems to work on. And there's a bunch. These are just practice problems. This is not a study guide. This is a practice problem. Practice final. If you go to go back. This is just a little intro, actually. That one's less important. You can watch just a couple minutes of me talking. Those are the main ones to help you practice. What I also recommend is go back to week 8. And what's in week 8? The midterm. So notice that if you click on it, this gives you the key to the midterm. Kind of looks all funny on this one problem, but sorry about that. So this gives you the key to the midterm. So redo the midterm. Do you promise? Yeah, redo the midterm. Do it again. Okay? It's very likely that I'll pick a problem, some of the problems real similar to the midterm. Not all of them, but the final will have a problem or two that's very similar to what the midterm had. Okay, it won't be word for word or number for number, but similar stuff. So make sure you can do the midterm. Any questions on that? Make sure you can do chapter 10. Make sure you could do difference in means and difference in proportions, paired and independent. So that is important, and expect a problem on something in chapter 10. It's a good chance of it. And make sure that for chapter 8, 9, and 10, what are you not allowed to have in H0 and H1? For chapters 8, 9, and 10. Or chapter, sorry, 9 and 10 is what I meant. What can't you have in H0 and H1? Or I'll take off points. Don't see all jumping in. Should I tell you? You can't have words. You have to have symbols. So it's like mu equals 10 or P1 equals P2. Okay, so for the H0, H1, if it's coming from chapters 9 and 10, it has to have symbols. Chapter 11, that's where the words came in. Chapter 12, remember H0 and H1 are exactly the same. H0 is rho equals 0. H1 is rho is not equal to 0. Hopefully you remember that. Okay, I'm kind of going on and on. What I want you to do is spend time practicing problems. Study a lot. Study a lot. I want you all to do well, but I can only grade you on what you do. So study a lot, practice, practice, practice. I will be, even though this is our last webinar, tomorrow, I'm going to repeat this webinar. You don't have to go to it because I'm saying exactly the same things. And there won't be another webinar, but I'll be keeping my office hours. I'll be checking the Q&A forum. I won't be checking the project discussion forum because that's over. Okay, in fact, tomorrow I'm going to start reading your projects and grading them. Okay, I've already started a little bit today, but the project discussion forum is over. Now it's Q&A forum. So I will be reading your Q&A forum questions, and I'll be happy to answer any questions you have. I think I want to give you the secret word, which means I need to share again. Paint. And let's. Okay, so secret word of the day is thank you, because you guys have made it this far, which is really good. Hopefully you'll keep going and do well. And I want to thank you for all the work you've done and for your dedication and coming to the webinar, which is always a good thing. So thank you for not putting up a big fuss and working hard and having a good attitude. So what I will do, as always, is I will stick around and answer any questions that the three of you might have. Probably about the final exam, but maybe about ANOVA too. Anything you need to ask me until it's time to say goodnight. In fact, I'm going to unmute you all because this is the time to talk. This is your turn. I'm going to try to unmute you all. Any questions at all?
I don't have any.
Okay. But as always, I'm happy to answer any questions you have. It's kind of what the webinars are for. And I'm happy to answer on the Q&A forum too. You should have questions coming up as you're working on problems. So any questions?
I don't have any questions either, but the Q&A will come in handy, I'm sure.
Okay, yeah, and I'll be watching it. I'll definitely be watching it. This last weekend was tough. My laptop died, so I had no computer over the weekend. It was tough. Smartphone only, that's not my style. Okay, but you can say goodnight if you don't have any questions.
Okay.
Thank you.
Thank you.
And thank you. Okay, and for all of you who are watching this as a archive webinar, thank you for watching this, and don't forget to let me know when you're taking the test, and I hope it all goes well for you next week when you take the final exam. So have a wonderful night.